All right, let's get right into it. Today, we are cracking open the JavaScript engine to see what really makes it tick. We're going to follow the entire journey of your code from just a plain text file all the way to a living, breathing, interactive web page. This is going to cover those core concepts you absolutely need to nail for your next interview. So here's our game plan. We'll start with the foundation, how JavaScript even runs in the first place. Then we'll see how it talks to the web page through something called the DOM. After that, we're diving deep into the heart of the language, functions, and that infamous this keyword. From there, we'll tackle the tricky world of asynchronous JavaScript. And finally, we'll wrap up with some performance tips that will really set you apart.
Okay, let's start at the very beginning. Before a single line of your code actually does anything, the JavaScript engine is already busy behind the curtains, setting the stage. This is the invisible work that makes everything else possible.
You've definitely seen this, right? It's one of those classic JavaScript gotchas. You call a function on line 5, but the function itself isn't written out until line 10, and somehow it just works. Well, that's not magic. It's a very specific, very important mechanism of the engine. And that mechanism is called hoisting. The easiest way to think about it is that JavaScript reads your code in 2 passes. On the first pass, it just looks for declarations, all your variables and functions, and kind of sets up memory for them. Only after it's done that does it go back for a second pass to actually execute the code. This example shows it perfectly. Because the engine already did its first pass, it knows a variable called a exists when it gets to the console.log. Now, it hasn't been given a value yet. It hasn't been assigned anything, which is why we get undefined instead of a crash. The declaration was hoisted to the top. Okay, so hoisting explains how the engine prepares our code, but what manages the actual order of execution, especially when you've got things happening at different times? Well, that's the job of the master conductor of JavaScript, the event loop. It's what keeps everything running smoothly without getting stuck. And here's the play-by-play. All your normal synchronous code gets run one by one on something called the call stack. But if you have an async task like a timer, it gets handed off to the browser's web APIs to handle in the background. Once that timer is done, its function doesn't just jump back in, it waits patiently in the callback queue. The event loop has one simple job. It constantly checks, is the call stack empty? As soon as it is, then it takes the first thing from the queue and puts it on the stack to run. That's the secret sauce to JavaScript's non-blocking nature. All right, we've got the engine's internal workings down. Now let's connect all that theory to what the user actually sees on their screen. How does our JavaScript code actually reach out and touch the web page? The bridge between our code and the page is the DOM, the Document Object Model. Basically, the browser takes all your HTML and converts it into this big, tree-like structure of objects. Our JavaScript can then use this model to find, change, add, or even delete any of those elements. It's literally how we make a static page come to life. Now, what happens when a user clicks a button? The event doesn't just appear out of nowhere. It actually goes on a little journey called event propagation. It has 2 phases. First is the capturing phase, where the event travels down the DOM tree from the very top to the thing you clicked on. Then comes the bubbling phase, where it travels back up from that target all the way to the top. And by default, this bubbling phase is when our code usually listens for events. But here's the pro tip. We can actually control this. See that third argument in addEventListener, the one most people just ignore? If you set that to true, you're telling the browser, hey, I don't want to wait for the bubble. I want to catch this event on its way down. During the capturing phase, it's a super powerful way to manage complex event interactions. Okay, now we're getting to the absolute core of the language, functions. And you can't talk about functions without talking about probably the most powerful and definitely the most confusing keyword in JavaScript, this. Honestly, mastering this is a huge level up for any developer. So how in the world do you figure out what this refers to? Well, here's a golden rule that will get you the right answer almost every time. Just look at how the function was called. Whatever is immediately to the left of the dot, that's your this. If you see user.getProfile, then inside getProfile, this is user. Simple as that. It's all about the call side. But what if we need to force this to be something specific? We've got 3 amazing tools for that. .call and .apply are almost identical. They both call the function right away, letting you specify what this should be. The only difference is that .call takes arguments one by one, while .apply takes them as an array. Then there's .bind. It's the odd one out. It doesn't run the function,
Instead, it creates a brand new function that has its this value locked in permanently, which you can then call whenever you want. So far, we've mostly talked about code that runs instantly. But in the real world, you have to wait for things, like fetching data from a server. This is the world of asynchronous JavaScript, and we're going to look at how we went from total chaos to the clean solutions we have today. In the early days, all we had were callbacks. And if you needed to do one thing after another, you ended up with this, the infamous pyramid of doom. Your code just keeps nesting further and further to the right, creating this unreadable, unmanageable mess that's an absolute nightmare to debug. The first real answer to this problem was promises. You can think of a promise as an IOU. It's an object that represents a value that you don't have yet, but you will in the future. It starts off as pending, and eventually it will either be resolved with the value you wanted or rejected with an error. And this is the magic of promises. Instead of nesting, we can chain. You start a task, and then you do the next thing with its result. Then you do the next thing. It creates this beautiful, flat, easy-to-read flow of operations. And if anything goes wrong anywhere in that chain, it all gets funneled down to a single dot catch at the bottom. It's just so much cleaner. Which brings us to today and the modern solution, async await. This is really just a prettier way to write promises. By marking a function as async, you unlock the await keyword. Now you can just await a promise, and your code will pause right there until it finishes, and then give you the result directly. It lets us write asynchronous code that looks synchronous, making it incredibly intuitive. Okay, we've done it. We've covered the core mechanics, our code works. But is it fast? Is it efficient? This last part is all about the polish, the key optimizations that really separate the pros from the amateurs. So let's run through some heavy hitters. Caching. This is about telling the browser to save files so it doesn't have to download them again. Compression, using tools like gzip to make your files smaller so they download way faster. Async and defer. These are attributes you put on your script tags to make sure your JavaScript doesn't block the rest of the page from loading. And finally, using a bundler like Webpack. This tool can package all your code efficiently and use clever tricks to make sure users get the latest version without re-downloading things they don't need to. And that's our whole journey, from the deepest part of the engine all the way to a fast, polished experience for the user. But look, the learning never really stops, does it? The JavaScript world is always changing. So the real question is, what's the next core concept you're going to sink your teeth into and really master?